So good morning students, welcome back. Today in this chapter magnetism, we are going to discuss magnetic field line and its properties. So let's start topic with the definition of magnetic field line. Okay, look at students, this is a bar magnet. Around the bar magnet or any other magnet, there exists magnetic field, but we cannot see the magnetic field. But if you want to draw the magnetic field, okay, if you want to represent the magnetic field, we have to take some help of some imaginary lines. That imaginary lines represent the direction of magnetic field, and that is said to be magnetic field line. So we'll discuss two definitions. Okay, so let's start. It may be defined as the curve, the tangent to which at any point gives the direction of magnetic field at that point. I'm going to explain. Look at, this is magnetic field line. A point, B point, C point. So what is magnetic field line? It is a path, okay, on which when we draw the tangent, this is the tangent at A, this is the tangent at B, and this is the tangent at C point. So that tangent will represent BA, direction of magnetic field at A point, direction of magnetic field at B point, and direction of magnetic field at C point. So what is magnetic field line? The technical definition is, it is a path, straight or curved, in such a way when we draw tangent on it, that tangent will represent the direction of magnetic field. So basically what is magnetic field line? It is imaginary lines around the magnet, okay, that always represent the direction of magnetic field. Okay, magnetic field lines are imaginary lines, okay, we assume it around the bar magnet or any other magnet that shows direction of magnetic field. Okay, it represents the direction of magnetic field. It may also be defined as a path along which a unit north pole would tend to move if free to do so. Okay, same, it's showing the direction of magnetic field from north to south. So basically, simple, it is an imaginary lines around the magnet that always represent the direction of magnetic field is said to be magnetic field line. Either we can say it is a path, straight or curved. When we draw tangent on it, that tangent will represent the direction of magnetic field. Basically, it's showing the direction of magnetic field. Now students, we'll discuss its properties. Okay, so let's start the first properties. Now students, the properties of magnetic field line. See the first properties. Look at students, this is a bar magnet, this is north pole, and that is the south pole. Okay, our first property is what? Magnetic field lines always travel north pole to south pole outside the magnet. Look at, this is the magnetic field line. It is traveling, okay, from north to south, outwards the magnet. Okay, look at like this. Okay, so simple, starting point is north pole and ending point is south pole outside the magnet. Look at, these are the magnetic field line that is traveling from north to south outside. But what happened in inside? Inside, south pole to north. Inside it travel, look at, from south pole to north. That's why we can say magnetic field lines forms the closed loop, because outside north to south, inside south to north. That forms the closed loop, closed surface. It forms a closed loop, closed surface. Understood? Now fourth point, the lines of force never cross each other. It means two magnetic field lines never intersect each other. Why? If they intersect, then what happens? Look at, this is the first field line and that is suppose second field line. If they intersect, if they do so, then what happens? I will draw tangent intersect. Okay, then what happens? This is the first one and this is the second one. I draw tangent, look at, this is the first one, I draw tangent on first, B1. I draw tangent on second, that is B2. So what we are observing, if they intersect, if they do so, then we get two different directions of magnetic field at same point. That is not possible. That's why field lines of force never cross each other. Two magnetic field lines never intersect each other. because if they do so, we'll get two direction of magnetic field at a single point by drawing tangent, and that is not possible. At one point only one direction can possible. Okay. Now fifth property, they start from an end on the surface of a magnet normally. Actually, field line always start and end. Look at like this. Normal to the surface, it will form 90 degree. It end and start perpendicular to the surface. Okay. Strength of magnetic field lines are maximum at poles. Actually, at these poles, okay, the magnetic field density is more. Look at a particular area there is a more field line. That's why it is maximum attraction power at poles as compared to rest part, because it close the north and south pole. Okay, the strength of magnetic field line in per unit area is more. That's why attraction power at north and south will be more. Understood, students? So these are the basic properties of magnetic field line. Okay, students?